Hello friends, welcome to my YouTube channel RF Design Basics. So in this video, I'll be discussing about the Laplace transform. So the basic definition of the Laplace transform is, it is an integral transformation of function ft from the time domain, that means ft is in time domain, into the complex frequency domain, which will give you the fs. The fs is equal to integration of ft e to the power minus st from minus infinity to plus infinity. But since we are studying this Laplace transform for the purpose of circuit theory, so we will limit our study for the t greater than 0. So the expression will convert into fs equal to 0 to infinity ft e to the power minus st dt. And the reverse calculation means, if you have been given with fs and if you are calculating the corresponding time domain function, then this is called inverse Laplace transform. And when you convert from ft to fs, this is called Laplace transform. So from time domain to frequency domain, it is Laplace transform. From frequency domain to time domain, it is inverse Laplace transform. Now let us try to apply this for few basic functions, and we will try to find out their Laplace transform. So first of all, let us consider the basic function ft, which is equal to u of t. As you know that u of t is equal to 1 for t greater than 0, and this will be equal to 0 for t less than 0. So let us apply this in finding the Laplace transform. So fs will be 0 to infinity our function ft is ut e to the power minus st dt, which is equal to, since we are taking only 0 to infinity, that means for t greater than 0, so it will become ut is 1 into e to the power minus st to the minus st, and then dt, which is from 0 to infinity, which can be further calculated as e to the power minus st, integration of e to the power minus st is same, divided by its coefficient, which is minus s, and it will be from 0 to infinity. So it's e to the power minus infinity minus e to the power 0 divided by minus s, which is 0 minus 1 by minus s, which is 1 by s. So that means the Laplace transform of unit step function is 1 by s. Similarly, we can take another example as e to the power minus at ut. So ft is e to the power minus at ut. This ut is taken so that we will only take the function for t greater than 0. For t less than 0, this will be multiplied with this function, so it will give you 0. So e to the power minus at, for t greater than 0, it will be e to the power minus at, and for t less than 0, it will become 0 for t less than 0. That's why we are taking only positive time. So every function will be multiplied with ut. So it will become, if you apply the formula, it is 0 to infinity, then this function e to the power minus at ut, then e to the power minus st dt. So this is our basic formula for this. Apply that and then integrate it. So this is 0 to infinity, and you know that for t greater than 0, ut is 1, so you have just function as minus s plus a t dt, which can be integrated as e to the power minus s plus a t divided by minus s plus a, which is integrated from 0 to infinity. So this is equal to, if I put infinity over here, so if t is infinity, the entire thing is e to the power minus infinity. So we can write e to the power minus infinity. Then when we put 0, it will become 0. So minus e to the power 0 divided by minus s plus a, which is nothing but 1 by s plus a. So if we have any function which is having e to the power minus at, then we have the transform as 1 by s plus a. Similarly, you can find out different types of Laplace transform. In next video, I will discuss about the Laplace transform of few basic functions so that we can find out the inverse Laplace transform by bringing into this form. Thank you.